So let me give you the definition of product of two matrices. Okay, please write this down, because unlike regular multiplication, it's a little bit different. So to multiply an M by N matrix, you must have an N by R matrix. I'll give you a minute to write that down and explain what that means. But in order to multiply an M by N matrix, you have to have an N by R. So what this means is, like, if I'm saying I want to multiply a 2 by 3 matrix to another matrix, that matrix must be start with a what here? 3 by whatever, 5, 1, doesn't matter. These two, whatever you multiply, whatever it ends with has to start with, whatever the column is here has to be the row here. You can't multiply it unless that occurs. So very strange, because you would think, can't I just multiply straight across element to element? It just doesn't work. It has to be an M by N and M by R. Another thing is, in matrix multiplication, this is not true. An A times B is not the same as B times A. And it's because of this rule right here, meaning if I had a matrix A was a 2 by 3 and matrix B was a 3 by 5, I could multiply those together because this 3, what it ends with is what it starts with. But if I switch that around and I did the 3 by 5 times matrix A, which is 2 by 3, are those the same? No. Quick question, by the way. Do you know what the resultant matrix would be if I had a 2 by 3 and a 3 by 5? Do you think you know what it is? You should know what it is.
2 by 5.
2 by 5. That's right. Okay, so just so you know, that's why this is important. And that's what we're going to focus on for this first part of this lesson, multiplying matrices. I won't ever give you anything too complicated. Like I told you, if you do end up, if you're a computer person, or if you're going to be a math person, you never know what the Lord will call you to. I did not think I was going to be a math person, so FYI. But if you're going to be taking that linear algebra course, I mean, this is all you do. You actually do so many by hand. It's crazy. Example 1. Let A equal 7053. And then we're going to let matrix B be 3, 5, negative 3, 4, 6, negative 3. And then we're also going to have C. And I want you to find AB, AC, BC. So let me tell you, first of all, find the dimensions. Because you can already actually not have to do a problem by just finding the dimensions. So here's what I mean. What's the dimensions of this one? 2 by 2. What's the dimensions of this one? 2 rows, 3 columns. What's the dimensions of this one? Also 2 by 3. Would I be allowed to multiply A to B together? Yes. Would I be allowed to multiply A with C? Yes. What about B with C? No. It ends in a 3 and starts with a 2. So this right here, this is what you would write on homework tonight. Not possible. So just by finding where that happens, you can actually eliminate a problem. So out of the 3 we have to do, we actually have to do 2. So pretty cool. All right. You've got to watch me do this first before you actually write it down. So I'm gonna show you how to do AB, and then you're gonna do AC on your own. So AB, first things first, the dimensions of A was a 2 by 2, the dimensions of B was a 2 by 3. So again, the resultant matrix will be a 2 by 3. So what I do is I give myself this kind of like a blank matrix. Like it's a 2 row by 3 columns. So I kind of give myself a little blank here because if I don't do that, I'm sure I'm going to mess up. I'm going to put like the number 1 over here on the row when it should be on the column. So give yourself a little blank here. Yes, Gray? It's always your front and your back numbers once these are the same. Okay? All right, so now watch me. Don't write anything down. Just watch what I'm doing, and then I'll explain it. So again, Miss Davis, you think she's crazy. She is, but love her. Her RC Cola thing is actually helpful because you always multiply the row with a column. The row with a column. So you take the entire row of A and you multiply it to the entire row of B, element by element, and then you add them. So here's what I mean. Watch my fingers. I take element 1 from here, multiply those together. What do you get? 21. I'm just going to write it down here so you see what I'm doing. 0, multiply that with 5. What would that be? That's easy. 0. Add that together, and that is your answer in position 1. Okay? Now, keep this row, but move the column. So now I do this column. So I'm going to do 7 with -3 and add that to 0 times 4. Well, again, having a 0 is really your best friend. So 7 times -3 is -21. And then 0 times 4 is 0. 21. So -21. And then you do it here. 7 times 6 is 42. And then a 0 again. So 42. Let me do it on the next row so that makes more sense here. I'm going to use red. So for this bottom row, I take 5, 3, and I do it again with this one. So watch again what's going to happen. 5 times 3 is what? 3 times 5 is? You add those together and you get 30. Move to the next column. 5 times -3 is -15. 3 times 4 is 12. -15 and 12 make -3. 5 times 6 is 30. And then 30 and a -9 make 21. Okay? See if you can do now AC. See if you can do the A with the C. And I believe it'll be the same dimensions, right? Yes. Can check it on the calculator tonight, obviously. I think I even gave you odds, so you could go to the back of the book and check it. I'm going to actually show you 2 ways to do this. I'm going to show you the way Miss Davis showed you last year. Everything you need for a matrix is in this button right here called Matrix. You've all seen that before, right? If you don't remember how to input into a matrix, when you hit second matrix, it says names, math, and edit. You're going to actually go over to edit. I did this with yesterday's class, so that's why it's already in here. It's a 2x2 matrix, and you just put 7, 0, 5, and 3. And then you do the same thing for matrix B. Whoops. And there's my 2x3 matrix, 6, -1, 4. And then when you go to the home screen, you go back into matrix, and you just hit number 1, A, times second matrix B. And you should have gotten out 42, -7, 28, 36, -11, 17. Is that what you have?
Yes.
Then you did very good. I want to show you another way, though, and I will give props to where props is due, and I'm shocked that I have his brother right now, but Christian Carpenter is the one who showed me this. I never knew it existed. Yeah. I know. If you hit alpha zoom, this, it'll say frac func matrix. You can actually type input a 2x2 matrix right now. Actually, up to 6x6 you could do. But if you hit 2x2 and it comes up with a 0 matrix, and you can input right now this matrix 7, but you can't hit enter. You have to use the arrow button. 7, 0, 5, 3. Then you hit alpha zoom, and we're going to multiply that by a 2x3. Whoop, come on. 2x3. Have you ever seen this one before?
No.
Yeah. And then you're going to do 6, -1, 4, 2, -2, -1, and hit enter, and there it is again. So I would use that front one on the home screen like for really quick problems because again, I'm going to let you eventually use this. You know I will. But When you do longer, complicated ones, and when you do operations on matrices, use the actual inside the matrix button. Yes, Liam? Oh, okay. Wonderful. All right, so there's that. So we got through that one. Let me now talk about inverses, and then we're almost finito here, okay? So an inverse matrix is only for square matrices. And if you don't remember what I talked to you about on Monday being a square matrix, square meaning it's a 2 by 2, a 3 by 3, 4 by 4, 5 by 5. The definition for inverse is that a matrix A times its inverse, this is the symbol for the inverse of A. It doesn't mean A raised to a -1. It actually just means inverse. Must always equal the I, meaning the identity matrix, okay? So this is the inverse of A. This I stands for the identity matrix, which again, we talked about last class. Identity matrix is ones and zeros, ones along the diagonal, zeros everywhere else, okay? So we are going to, on your next part of your homework tonight, we'll say determine if matrix A and matrix B are inverses. And they'll give you matrix A, and we'll keep it easy. We'll do a 2 by 2. So if you're determining if two matrices are inverses, then all you have to do, according to this definition, is multiply them together and get out an identity. If you get out the identity when you multiply them together, if you have to get ones along the diagonal and zeros everywhere else. If you got like 1 1 0 0, that's not going to cut it. It has to be 1 0 0 1. Okay? But all you'd have to do is multiply A and B together. Actually, you're supposed to. You have to check that AB and BA are identities. I'm going to let you just do AB by hand. You can do BA in the calculator, okay? So I'll be fine with that. So let's see if we can do AB right now. Let's see if we get out the identity matrix. And again, practice this because you'll get really good at multiplying. But take this row, multiply it by this column. What's a 4 times a negative, 4 times 2? I'm sorry, -4 times 2 is -8, right? 3 times 3 is 9. What's a -8 and a 9 make? 1. Now do it here. 4 times -3 is -12. 3 times 4 is +12. That makes 0. So it looks like I'm going there. Now I'm going to do 3 times 2, which is 6. -2 times 3 is -6. That makes 0. And then I get 9 and a -8 again, which is 1. So going the direction of AB, it does give you that identity. Don't always think that BA is going to. It's happened before 1 or 2 times that it hasn't. But BA does work out. I just will let you know that. Okay. So yes, they are inverses is my answer. Okay. That's the question said, determine if they're inverses. Yes, I just showed you how to determine if they're inverses. Okay. And by the way, to find an inverse on the calculator, so if I wanted to find the inverse, well, no, actually, I want you to do it by hand first, and then I'll do it on the calculator. My bad. Let's do the inverse of a 2 by 2 matrix. I am not going to do it 3 by 3. I'm actually going to prevent you from doing a 3 by 3 by hand. You should be thankful. Let A equal the matrix A, B, C, and D. Then A is invertible. I'll explain what that means. If and only if AD minus CB does not equal 0. And A inverse is equal to 1 over AD minus CB times It doesn't this look exciting? I love when math looks hard, but really it's not. Write this down. Let me explain what it all means because it's really not terrible. Again, if you take linear algebra course, this is what it's like. It's a lot of definitions and then applying those definitions to actual problems. But this is the inverse for a 2 by 2 matrix. Okay. Then A is invertible. Let me explain what this word means. It's just a fancy name for it has an inverse. If here's A, then it has an inverse, okay? Why didn't they just say it has an inverse? I don't know. I don't make up the words. I teach the words, okay? If and only if AD minus CB does not equal 0, where are they getting those from?
Diagonals.
The diagonals, exactly. If you take the multiplication of this diagonal, AD, and you subtract it from this diagonal, it cannot equal 0. If it does, you're done with the problem. You actually say there's no inverse, I'm done. Okay, which will happen, you'll be like, woohoo. If it gives you a number like 2 or 5 or 12, then you have to follow this formula. What does this formula say? Well, this formula says 1 over, where is this again? Diagonals. And then what did they do here? What did they do to my matrix? Look at what they did. Can you see what they did? Yeah. It was A, B, C, D. Now it's what? D and A, what did they do to that?
They rotated.
They switched them. And then what did they do to this diagonal? They made it negative. Okay, so I mean, this is a crazy formula. I can't believe somebody figured it out. I can't believe it either. Okay, so here's our last example. We're going to find the inverse of A if A is equal to 8, -5, -3, and 2. And then we're going to find the inverse of B and be done. Okay, so again, let's follow the formula. A inverse says 1 divided by, now be careful though, you always have to do the left diagonal minus the right diagonal. Left first. So 8 times 2 is what? 16 minus, what's a -3 times -5? Isn't that positive 15? Well, that didn't give me 0, so I'm not going to stop. So 16 minus 15 is 1, so really this is just 1. Then multiply that to the matrix. What do? I flip this diagonal. I flip the 8 and the 2, so I'm going to write 2 here, 8 here. And then what am I going to go this way? What am I going to make these diagonals? +3 and +5. So 1 over 1, like if this was the number 5, you would actually just multiply everything by 1/5. If this was like 1/3, you'd go 1/3 times 2, 1/3 times 3. But this is 1 over 1. So my final answer is 2, 5, 3, and 8. That is my inverse. Do B for me. Okay, I'm scared because I feel like there's only 3 people getting it because you all should be stopping right now. Do you know why? Because it's 0. Good. Okay, good. All right, maybe you're just all drawing things or something. Yeah, you get 6 minus 6. Can we ever have 0 in the denominator? No, so you're done. So you would say this has no inverse. In the calculator, though, calls it a singular matrix. And I think it comes from something being like Latin, like singulare, I don't even know. But again, just to show you, because I always think it's good to see it here, if I hit Alpha Zoom, thank you, Christian Carpenter. Oh, come on. See, this is why I do like this way, and sometimes it annoys me. Hit enter. So 8, -5, -3, and then 2. To find the inverse, you have to arrow over and then hit this x to the -1 button. So it looks like that, with that little -1 up there, hit enter, and then there's your inverse. If you did this one, it would actually say error singular matrix. That's all. And then you'd be done. So cool. How do we feel about this? Exciting stuff, right? I know. It's actually pretty